Hello everyone, welcome back to my channel. Have you ever wondered how developers build applications once and run them anywhere without worrying about it works on my machine? Well, that's exactly what Docker solves. In today's session, I'm going to walk you through Docker from a practical, real-world perspective, not just theory, but how you can actually use it in your projects. By the end of this video, you'll understand what Docker is, why it's powerful, and how to start using it like a pro. Let's get started. Before we dive into Docker, let's make sure your environment is ready. You'll need Visual Studio Code installed, or you can use your native terminal if you're on a Mac. Also, make sure you have a server up and running and you can connect to it remotely, because everything we'll be doing in this course will be hands-on and practical. Before we jump in, let me quickly walk you through what we'll be covering in this session. We'll start by understanding what Docker is and why it's such a powerful tool in modern development. Then I'll show you how to use Docker on your system step by step. After that, we'll go through some essential Docker commands that you'll be using regularly. And finally, my favorite part, we'll do a hands-on practice using the HTTPD Docker image so you can see everything working in real time. Now let's really understand what Docker is. Docker is a containerization platform, and what that simply means is that Docker helps you package your application together with everything it needs to run. Think of it like this: instead of saying install this, install that, configure this, you bundle everything into one unit. So whether I run my app on my laptop, my AWS server, or someone else's machine, it behaves exactly the same. And that's one of the biggest problems Docker solves: environment inconsistency. For example, in our Esthytech projects, if I build an app locally and send it to you, you shouldn't have to struggle to run it. Docker ensures it just works. So what exactly is a container? A container is simply a package that contains your application and everything it depends on. Everything means everything. Your code, your libraries, your runtime, your configurations, all bundled together. So instead of worrying about, does this server have Python installed? Or is this version compatible? Docker already handled that. That's why containers run quickly and reliably anywhere. One powerful thing about containers is isolation. Your application is completely separated from the host system and from other applications. So even if two apps need different versions of the same library, they won't conflict. That's why in real-world DevOps workflows, containers are heavily used from development all the way to production. Now let's talk of Docker image. What is a Docker image? Think of a Docker image as a template or blueprint. It's not running yet, it's just a packaged definition of your application that contains code, runtime system, tools, libraries, configuration. It is read-only and reusable. For example, when we use the HTTPD image later, that image already contains Apache installed and configured. So instead of installing Apache manually, we just use the image and run it. Image versus container. Again, this is very important. Don't mix it up. An image is just the package, but the moment you run that image using Docker, it becomes a container. So image equals what you build, container equals what you run. In our demo later, when we run the HTTPD image, we'll actually be creating a live container. Now let's look at Docker containers features. Docker containers are standardized, meaning it runs anywhere. Docker containers are lightweight because they don't carry a full operating system like virtual machines do, thus highly efficient. Instead, they share the host system's kernel. That means faster startup, less memory usage, better performance. And from a security standpoint, Docker provides strong isolation, so applications don't interfere with each other. So why are companies and engineers using Docker everywhere today? First, it removes the classic problem. It works on my machine but not in production. Second, it makes deployment faster. You don't need to configure servers manually anymore. Third, portability. You can take your application from your laptop to AWS to Kubernetes and it will still work the same way. And finally, Docker fits perfectly into CI/CD pipelines. which is something we use heavily in DevOps. Now, this is a very important concept, Docker versus virtualization. If you've worked with virtual machines before, you already know that each VM runs its own full operating system, and this is possible with the use of hypervisor. That means if you have 5 applications, you might have 5 separate operating systems running. That consumes a lot of resources, CPU, memory, and storage. Now compare that with Docker. Docker containers don't need a full operating system for each application. Instead, they share the host system's kernel. So what does that mean? Containers are much lighter, they start faster, and they use fewer resources. That's why in modern cloud environments, Docker is preferred for application deployment. Let's break this down visually. On the virtualization side, you can see that each virtual machine includes its own guest operating system. So the structure looks like hardware, hypervisor, guest OS to application. Now look at Docker. Docker removes that extra operating system layer. So instead, we have hardware to host OS to Docker engine to containers. That's why containers are lightweight, because they don't duplicate the operating system. This diagram shows how Docker works behind the scenes. On the left, we have the client where we run Docker commands. Those commands go to the Docker daemon on the host, which does the actual work. It pulls images from the registry like Docker Hub and runs them as containers. So simply, we send a command, Docker processes it and runs our application as a container. Build, pull, and run, that's the Docker workflow. If you remember just one thing from this section, let it be this. Virtual machines virtualize the hardware. Docker containers virtualize the application. And that's why Docker is faster, lighter, and more scalable. Now, if you really want to understand virtualization in depth, I already created a full video where I explained virtualization step by step, including how it works in real-world environments. I highly recommend you watch that video after this one so you can fully connect both concepts together. Now, before Docker, developers faced a very frustrating problem. It works on my machine, but not on yours. Let's say I build an application on my laptop, everything works perfectly. Then I send it to you, and suddenly it fails missing dependencies, wrong versions. Now we start debugging things that are not even related to the code itself. That's the problem Docker solves. Docker ensures that the application runs exactly the same, no matter where it is deployed. So how do we actually start using Docker? First, we need Docker itself installed on our system. Then we use something called Docker Hub, which is like a repository where we download ready-made images. And finally, we run those images as containers. Now for Docker Hub, I already have Docker installed on my system, so I won't go through the full installation process in this video. But don't worry, if you don't have it installed, you can check out quick installation guides on YouTube, or even better, you can watch my own videos where I walk you through it step by step. Now let's quickly create an account, launch your browser, go to hub.docker.com, click on register at the top. Fill in your details. Important tip, don't check the send me occasional updates box. Agree to terms and policy. If your username is taken, just tweak it slightly. After that, sign in with your email and password. Choose the free personal plan. Once you're done, Docker will send you an email. Open your email and click verify email address, and that's it. Your account is ready. Install Docker on your server. Now, there are 2 ways to install Docker on a server. The first method, using Terraform, which is automated. The second method, manually installing Docker on an EC2 instance. But in this course, we are going with Terraform, because as DevOps engineers, we don't like doing things manually. We automate everything. Once our Terraform script runs successfully, you will get 2 important outputs: your server's public IP address and the SSH command. To connect to your server, make sure you copy and save them, because we use them in the next step when connecting remotely. Now let's move into Visual Studio Code and actually see this in action. Okay, so let's get our environment ready. We are going to go to Visual Studio Code. So let's open Visual Studio Code. Okay, let me bring my Visual Studio Code closer. So what we are going to do right now, you just want to go ahead and close the window and create your environment. Okay, so we have our bash already. Should in case you are not having bash, you are having things like PowerShell, you can change that and use bash. So we are going to use bash. So this is the very first thing we want to do. Before we continue, I just want to quickly mention something. There was quite a bit of background noise while I was recording this part, so I decided to mute the original recording and do a clean voiceover instead, so you can clearly follow along without distractions. Now, in this section, we are going to set up the lab environment that we'll be using throughout this Docker course. Here's what we'll be covering: cloning the code from GitHub, understanding the Terraform code, and finally, launching our lab. Before we begin, make sure you have the prerequisites ready. You need Terraform installed and also the AWS CLI installed and configured on your machine. Also, very important, you can find the GitHub repository link for this project in the description section of this video, so make sure you grab it from there. Now, I already have this project cloned in my environment, so I'll just navigate into my existing folders. But if you're setting this up for the first time, you can follow these exact steps. Start by creating a directory. You can name it anything you like, but I'll be using DevOps Lab. Then navigate into that directory. Next, create another directory called Docker. Again, you can name yours however you prefer. Then move into that Docker directory. From here, you'll clone the project using the GitHub repository with the git clone command. Once the cloning is complete, navigate into the docker-lab directory. At this point, let's quickly look at what we have. Run the ls command and you'll see two important files, main.tf and install.sh. The main.tf file contains our Terraform configuration. It creates an EC2 instance and a security group, and it also opens ports 8000 to 8100. The install.sh file is a bash script used as user data. It installs Docker, adds the EC2 user to the Docker group, and starts the Docker service automatically. Now that we understand the code, let's go ahead and launch our lab. Run the following commands. Terraform init, we want to initialize our environment so it can download all the plugins and the binaries that is needed. Our backend, yep, successfully initialized. So we're gonna go ahead and Terraform plan. Yep. So the plan command will just show you what is going to be built, like a preview of what you're gonna install. Okay. Okay. So just go ahead and run the Terraform apply command. Let me clear first of all my environment. Then we record the command and we write apply. Okay, so now with the apply, we can set that dash auto approve. If we don't want to have any like creations, we write that the auto approve. Okay, so click on it. This will take about 5 to 10 minutes. Once it completes, you'll see an output that includes an SSH command. Copy that SSH command. So you're going to use this, but you want to use your own output, okay? Do not use mine to SSH. Okay, we literally SSH into it. You can see, use your own, do not use mine. So you have to copy yours and use. So you're going to copy your SSH command, then you paste it so that you can SSH. You have the SSH connection to your server. So now we have connected to our server. You can see this is our server. We have connected into our server. Then now we can now start the real logic. So let's clear the environment. And once you're inside, you can verify that everything is working correctly. And that's it. Your lab environment is now ready. Now let's get into the practical part, Docker commands. These are the basic commands you use almost every day when working with Docker. Don't worry about memorizing everything right away. The more you practice, the more natural it becomes. The first thing we always do is confirm that Docker is installed correctly. So we run docker -- version. If Docker is installed, it will return the version number, just like this. If not, then you need to go back and install Docker first. Docker info. First, I want to get information about Docker on this system, so I'll run Docker info. What this command does is it gives us detailed information about Docker, like the number of containers, images, storage, and system details. Now, if you look closely, there are no images available yet, and that makes sense because we haven't downloaded any image from Docker Hub. Now this is where Docker becomes powerful. To create a container, we first need an image, and we get that from Docker Hub. So I'll go to Docker Hub. I'm already signed in with my account. I'll search for Ubuntu. Now I'm going to select the official Ubuntu image. Always choose the official image when possible because it's verified and secure. Next, I'll copy the pull command provided, this. Now, back to my terminal. Docker pull Ubuntu. This command downloads the Ubuntu image from Docker Hub into our system. Important tip: make sure your Docker daemon is running. If Docker is not running, you will get an error immediately. Now let's confirm the image is available, Docker images. Now you can see the Ubuntu image listed here. Now let's quickly talk about something very important: tags. A tag represents a specific version of an image. If you don't specify a tag, Docker automatically pulls the latest version, but sometimes you may want a specific version. For example, Docker pull Ubuntu -resolute-202-60401. This will pull Ubuntu version resolute-202-60401 instead of the latest. In real-world environments, we always prefer specific versions to avoid unexpected changes. Now let's create a container from our image. First, get the image ID, Docker images. Next, we download an image from Docker Hub. For this demo, we'll use the HTTPD image, which is an Apache web server. So we run docker pull HTTPD. This command downloads the image to our system. Let's check it with this command. Docker ps-a, and now you will see the container with status exited. Now let's confirm the image is available, Docker images. So we are going to run docker run-i for the interactive mode, T for the terminal, D for detached mode, then --name. We are naming it web app, -p for a port that we are defining, and we are giving 8001 then we map it as the external port, then with the internal port. So now we use 80 because HTTP is opened on port 80. HTTPD, the image that we pull from GitHub repository, HTTP, for us to run our Apache apps. Okay, so we're gonna click enter. So our it's actually created. So we're just gonna go ahead and check it in our browser. So you can literally exec into it and check it within our terminal, but let's just go to the browser and see what we have. So let's take the IP address again. So let's go back to AWS. Okay, we go to AWS, we grab our port IP. What did I do? Okay, summary, check our IP address. That's the IP address. So go back to my notepad where I have it. Let me see if it's actually tied. Yeah, that is my external IP address, my external. Then now we're going to use the internal IP address. So we are mapping it to what port do we use? Let's go back to Visual Studio Code. What port do we use? Okay, that's it. So we are good. 8001. So we're just gonna take this command and run it on our browser. Click on our browser and paste. Oh, what am I doing? Paste it. What is happening? Okay, paste the command there and click on enter. So you can see it works. Let's go back to the Ubuntu example image we pulled previously and explain some basic concept with it. Now let's go ahead and check the images on our system. Run the command docker images, and as you can see, the Ubuntu image is now listed here. Now let's quickly rewind back to something very important: Docker tags. A tag represents a specific version of an image. If you don't specify a tag, Docker automatically pulls the latest version, and that's exactly why earlier we pulled Ubuntu both with a version and without a version, just to demonstrate the difference. When you specify a tag, you're pulling a specific version, not the latest. And in real-world environments, we always prefer using specific version to avoid unexpected changes. Now, let's create a container from our image. First, confirm your image again. Docker images. Then run docker run Ubuntu. Now, if you check running containers Docker piece, you won't see anything running. Why? Because the container exited immediately. To check all containers, including stopped ones, run docker ps-a. Now you'll see the container with the status exited. It exited because there was no active process running inside it. So now let's run it properly in interactive mode. Docker run. We can just recall the docker run -it, which the I stands for the interactive mode, while the T is for the terminal. So we are going to Ubuntu --bash. That's the correct way to run. So it's going to give us the bash interface. So it will give us the bash interface. We have actually run the command the right way because we don't want it to be existed, right? So we ran it the right way, and now we can see now we are inside the container. Now you are inside the container. Once inside, you can run commands like ls. You can see all the directories that we have. You can go ahead and run things like when it was released. We're gonna say cat/et/os release and click enter, and you can go ahead and verify the name of your Ubuntu, the version, when it was released. In short, it has a lot of details that you can go ahead and let's clear our environment and continue. So now you can see now we are not interacting with our container, right? So for us to leave this page and go back to our server, we're just going to run the exit command. And now we are now back in our server. Okay. Despite the fact that we have a container that is out there running, but it's showing that when we run Docker PS, it doesn't list anything. It shows empty, right? So when we say Docker PS-A, you're going to see the statue. They are all exited. So we want to run the command in the background. We don't want them to keep on showing exited. So we are going to run it in the background. So to do that, we say Docker. We're just going to bring back that same command, run the cursor and put the D for the detached mode. Okay. So now when we run this command and when we run Docker PS, you can see we have one that is upright, and you can see it has some weird name that it gives. You can always change this. As we continue with the lecture, I will show you how to do that. So now when we run the command Docker PS-A, you can see it will show you the three Docker containers that are out there, right? They're out there running, and you can see this is up, but these other ones, they're exited. So that's it. So I would like us to create a container with a custom name and a port. So we are going to do that by running the Docker run command dash name. I'm going to give, like, for the name, you want to always give your container a name. So the dash name equals to st underscore container. Okay, let me see. Underscore container dash p. Okay, dash p. That's for the ports. Then we're gonna give the port because we already have the range of 8,000 to 8,100. So we are going to rotate from that port. So we say 8,000. So now let's just give 881. Okay. We are within the range. Then our image, we are using Ubuntu. So let's use this image, the Ubuntu image, right? So we are going to go with Ubuntu. Okay, and click enter. So this dash name that we use here, it actually gives you a container name. So it avoid all these weird and boring names that when you run the command it actually gives. So it will give you your own custom name, not all these boring names. So it's going to give you your container name. That's what you want to know. Then the dash p here actually maps the port. That means the external port with the internal port. Okay, so that is just what happens. It looks like I did not run it correctly. Let me bring back the command. It has to map it, the external port with the internal port. So we're going to say it's 280. Okay, but once you already use this port, you don't want to reuse it because it will not work. So you're going to change the port number to 2, and now let's execute it. So you can now see, let me see. Oh, the name also is already exists. Okay, let's see. We already have this name already exists. So even if we change the port, the name already exists. So we have to have a different name. So we're just gonna bring back this command, guys, and just adjust it. So if we have to change the name, let's gonna say we're gonna use now 1. And once we change the name, we have to also change this port because it won't work. So we're gonna give port 3, then execute, and it's gonna work successfully. Okay. Container. So Docker. Let's check our container. Docker PS. With the Docker PS, we can see we have just one. and the other state is actually showing existed because we did not put the dash interact terminal, so we didn't. So we're just going to go ahead and exec into that container so we'll be able to use it. So if we run the command docker ps -a, we can see everything that's out there. So we want to literally use the one we have, this st1, this one. So we are going to use this. So let me clear this environment and bring back that command. Okay, so what we are going to do to exit into the running container so we can run command inside that running container, we are going to run this command docker exec. Okay, then the container's ID, you can use the container ID or your container name. So since we want to use this one, we are going to go here with this ID. You can run the entire ID or you can just copy the first three of the ID. Okay, so we have that. Then we're gonna run things like uname -r. Okay, so let's say uname -r so we can see the this demo is not running. My demo is not running. How can I say demo is not error response from demo container? This is not running. Okay, that's not a running container. So this is in a proc container ID and inner proc. Okay, so once we try to run exec into container that is not running, it will give you it's not running because the container has been exited, right? So the other container that we can run command inside is only this one that has been up for 5 minutes. So we are going to record it and take this command. This is going to be the command that we are going to run. So it's good for us to have that error so that I can demonstrate to you guys what was the issue. So now when we execute this, you can see docker exec require at least 2 arguments. Okay, oh, I mistake. So now we are executing what? So that's what we want to execute command inside a container. So this is what we did. So we have to write the other argument. So uname -r. So we're gonna go with uname -r. What happened? It's not running. I thought I just ran this is running. Docker exec. This command is exploding, right? They give it the wrong. Oh my god. It's not running, right? So I have to copy the right one. Let's okay. Copy this one. Okay, so bring back that command. Change it. You want to run command inside a running container, use the exec command. So this is it and it works. You can see it show you the uname -r. Okay, so you can use nfproc, whatever command that you want. So you can also attach to a container by using the docker attach command. So let's go ahead and do the docker attach. Okay, then you write the container ID. For example, we use that container ID and we enter. You can see we have attached into that container or we have logged into that container. So you see that's the function of docker attach command. So we can literally go ahead and also use like docker login. Okay, so for us to do that, you need your username and your password. So what you did is your username and your password. So you're going to go back to your GitHub repository and copy your username. My username is Esty. I want to click Esty. Docker command not found. The fuck? Okay. Oh, I see why it's showing Docker command not found, because I'm exited into a container. Okay, that's not what I need to do. Exit. Okay. Docker login. Now let's log into Docker Hub from terminal. Docker login. Enter your username and password. This is useful when you want to push your own custom images or manage your repository. In my case, I also have a custom image that I created. So let's pull this image from Docker Hub. Let me run this. Then let's verify the image was successfully pulled with the Docker images command, and here we have it. So now let's run our app with our custom image with this command Docker run -itd--name equals st_app st/devops-starter-p8005:ad. Oh, it failed. Why? The problem is order of arguments Docker is interpreting. Right arrow -p as a command inside the container. That's why we see exec -p executable file not found in $path. So let's fix this. We have to move the -p before the image name. We're going to say Docker run. We are running in the dash mode -itd. We're gonna say dash name Docker run in the interactive terminal detach mode. Then we are going to give the name, that dash name. So our name, we are going with Esthytech_app. Okay, -p for the port. We want to map our port. So let's go ahead. 8,000 and let's say 7. I feel like I've already used the other, so let's go with 7. Oh, we can go with 8 though. Let's use 8. Yep, to be sure that I haven't used that port already, is to map it to, since I'm using Python app, so that Docker can map it to 500. That is it. Then what is the name of the image? My custom image. So just grab my custom image and paste it here. Then we execute this command. So we have it here, shows that it's created. So let's see if our image is being run in our container. So we're gonna say Docker PS is literally running. I want to extend this command so I can see where it's being mapped. So remember, this is it, and it's been mapped to this path. So we are going to use this and go to our browser to make sure if our app is literally working or not. Okay, so we are going to go now to our browser to make sure that our app is reachable, right? our custom app is reachable. So I'm going to go to, this is a command. You want to use your IP address, the IP address of our EC2 instance, the public IP address of our EC2 instance, and the port that we open. So we click that. Let's go to our browser, minimize this, and go to our browser, paste it there, click on enter. Let's see, we can see our app is reachable. Do you see that? Our custom app that will be is reachable. Now that we have viewed our application and confirmed that it is running successfully, let's move on to the next step. In this section, we're going to look at how to manage our containers using the Docker stop and Docker start commands. First, let's go ahead and stop our running container. I'll run the Docker stop command and pass in the container ID. Now that the container has been stopped, let's verify its status. We run docker ps-a. This allows us to see all containers, including those that are no longer running. And as you can see, the container status is now exited. Next, let's go ahead and start the container again. I'll run docker start followed by the container ID. Now let's confirm that the container is back up and running. We'll run docker ps, and now you can see that the container is running again. So this is how we stop and restart containers in Docker, and how we verify their status using docker ps and docker ps-a. Now that we understand how to manage containers, let's go ahead and clean up our environment. First, we stop any running containers. Then we remove them using docker rm. This command deletes containers that we are no longer using. After that, we can also remove images using docker rmi. This helps free up space and keep our environment clean. And that's it for this section. You've now learned how to stop, start, verify, and clean up containers and images in Docker. Let's keep building. Since this was a practice environment, we want to go ahead and delete everything. So we're going to exit out from this server. We just exit out. Then we are going to close the environment. So we're going to run the command Terraform destroy. So we can destroy the entire lab. And that will clean the environment. So that is literally clearing your environment. So clear your environment. You don't want to allow everything to say yep. So you're gonna say yes. If not, you're gonna incur charges in AWS, and you don't want that. This is just for practice purposes. But in the real world, you don't have to be going to destroy. So you can see how we automate things, right? Now that you understand Docker, we're not stopping here. In the next phase, we're going to take these same skills and apply them to a real-world project. We'll be working with custom Docker images and deploying real applications step by step. And I'll be guiding you through my project, AWS DevOps Starter, step-by-step guide. This is where everything starts coming together, from Docker to real-world DevOps practices. So now, you're not just learning Docker, you're learning how to actually use it in production environments. Alright guys, that brings us to the end of this session. I hope this was helpful and gave you a solid understanding of Docker, both conceptually and practically. If you found value in this video, don't forget to like, share, and subscribe to the channel. Drop your questions in the comments. I'll be happy to help you out. And remember, the more you practice, the better you become. You can find more resources and guides on DevOpsProGuides.com. I'll see you guys in the next lesson, and keep building, keep learning.
Let's build the future.
One line of code, one dream at a time. From the cloud to the console, the rhythm flows. Innovation lives